Hello my dear students, we have already seen the general method for solving the sums based upon linear upon quadratic. Let us see some examples in this module. Now, the integral is of the type x cube upon x square plus x plus 1 dx. My dear students, you may wonder, sir, where it is linear upon quadratic. Exactly, it is not linear upon quadratic, but if I simplify further, it gets transformed to linear upon quadratic. Let's see the steps. My dear students, let us copy the question first. Now, this we have seen in 11th standard. We have done this in the revision part of 11th standard when we started the chapter. What do we observe in this case? I have an integral which has a polynomial in the numerator, polynomial in the denominator, and I can come to the conclusion that degree of numerator is greater than degree of denominator. And if it is degree of numerator which is greater than degree of denominator, come what may, I am supposed to perform actual division. I am supposed to divide in this case. So now, my dear students, are we going to divide the numerator with the denominator? Actually not. This being a very simple case, I can easily simplify by adding, subtracting 1. If I add, subtract 1, it is faster than actually dividing the numerator with the denominator. So my dear students, instead of dividing, what we will do here is add, subtract 1. So what we have here is x cube minus 1 plus 1 upon x square plus x plus 1, of which we will group x cube minus 1 together. So x cube minus 1 is of the form a cube minus b cube. We very well know the formula, which is a minus b. So x minus 1 into x square plus x plus 1, and that plus 1 remains separate upon x square plus x plus 1. Now, my dear students, if I consider the denominator to be a single unit, you know it is a single term, so I will have to separate the numerator. So let me copy the step and let's separate. So what we get is integral of x minus 1 into x square plus x plus 1 upon x square plus x plus 1 plus 1 upon integral of x square plus x plus 1 dx. Is that okay, my dear students? So in the first integral, you may very well understand that x square plus x plus 1 gets cancelled. So what is left is x minus 1 in the integral. Now, if I have x minus 1 dx and plus, can I say I1? Now, to integrate x minus 1 is not very difficult. It is of the form x raised to n. So can I say x minus 1 the whole square upon 2 plus of I1 and plus of C1. Is that okay, my dear students? So now my job is finding the value of I1, and I1 happens to be integral 1 upon x square plus x plus 1 dx. Coefficient of x square is already 1, so we can go to add, subtract a number to convert this into a perfect square. So x square plus x plus 1. Now let's fill up the blank there. Half into coefficient of x, so half into 1 by 2 into 1 the whole square, that's 1 by 4. So add, subtract 1 by 4. So my dear students, in the next step we can write 1 upon x square plus x plus 1 by 4 plus 3 by 4 dx, which is nothing but 1 upon x plus 1 by 2 the whole square plus root 3 by 2 the whole square. Now, this particular integral, we'll just copy it for our reference. And now which formula is applicable? 1 upon x square plus a square. So 1 by a. So 1 by root 3 by 2. Tan inverse of x plus half upon root 3 by 2 plus of c2. Now my dear students, this will be rewritten as 2 by root 3. Tan inverse of 2x plus 1 upon root 3 plus c2. Now we've got the value of I1 also. So let us find the value of I, which is x minus 1 the whole square upon 2 plus I1. So let us write here x minus 1 the whole square upon 2 plus of 2 by root 3 tan inverse of 2x plus 1 upon root 3 plus c2. Instead of that, I'll write it as plus c, where c is nothing but c1 plus c2. And that's your final answer. Now my dear students, there are certain sums of the same type where degree of numerator is greater than degree of denominator. So we'll have to divide in this case. No adjustment is possible. That's all we have in this module. Thank you very much.
Yes,